Radiation is a natural phenomenon that could cause severe damage to human beings by seriously affecting their DNA. The Martian surface has high levels of radiation due to its very thin atmosphere and lacks Earth's global magnetosphere. In addition to this, from time to time there are solar proton events that produce much higher doses of radiation.
Mars doesn't have a magnetic field, so galactic cosmic rays get through the thin atmosphere, solar flares, some of that gets through, and it can disrupt the DNA. So you need a habitat that shields the astronauts.
The Mars Odyssey spacecraft measured this cosmic radiation. It found that radiation levels in orbit above Mars are 2.5 times higher than at the International Space Station. A 3-year exposure to such levels would be close to the safety limits currently adopted by NASA. The effects on living organisms have been closely studied. Protons from cosmic radiation may cause twice as much serious damage to DNA as previously estimated, exposing astronauts to greater risk of cancer and other diseases. NASA is exploring a variety of alternative techniques and technologies, such as plasma deflector shields, to protect astronauts and spacecraft from radiation. Nevertheless, a 100% effective technique has not yet been developed. Another of the main challenges when it comes to sending manned missions to Mars is the huge per-person cost of the trip. In fact, it would not be at all feasible to create a self-sustaining civilization at its present cost. There are estimates, with the Apollo program as a reference, that calculate the present cost to be around $10 billion per person. It's essential to reduce this cost to undertake the building of a permanent base. This is precisely the goal set by SpaceX company.
SpaceX is a very impressive company. It was founded by an entrepreneur named Elon Musk, who really wanted to break the barriers and break the mold of the things that were stopping us from getting to Mars. And this includes both high-cost space launch, but also, frankly, the timidity of bureaucracy that's unwilling to accept the kind of risks that involve to just go for it.
According to Elon Musk, to make Mars trips possible on a large enough scale to create a self-sustaining city, the key factors are full reusability of rockets, refueling in orbit, propellant production on Mars, and choosing the right propellant. Full reusability is essential and truly the most difficult one.
That's very important. You know, up till now we've been throwing these rockets away after one flight. Imagine how expensive airplane flight would be if you threw it away after each flight. Boeing 747 seats 400 people, costs $400 million. If they had to throw it away after each flight, an airplane ticket would be $1 million a flight.
The next goal would be the development of a system to refuel spaceships in orbit. The ships would have dry tanks on leaving the Earth. This would help to reduce the costs radically. Finally, the third factor that Elon Musk stresses is the ability to produce propellant on Mars so that spaceships can return to Earth, as well as choosing the right propellant. The surprising advances that SpaceX is making indicate that they will soon be able to reduce the costs of the trip considerably. But sending a manned mission to Mars would still mean solving very important questions, such as being able to make a safe landing.
Landing on Mars is tricky. First of all, you use an aeroshield to slow yourself down from orbital speeds to subsonic speeds, and then you pop a parachute, and that brings you down to a slow velocity, and then you have to then do the final landing with rockets.
The relatively strong gravity and the presence of aerodynamic effects makes it difficult to land heavy, crewed spacecraft with thrusters only, as was done with the Apollo moon landings. Yet the atmosphere is too thin for aerodynamic effects to be of much help in aerobraking and landing a large vehicle.
On Mars, you have to go through the atmosphere. And the atmosphere is not your friend. Right? So when you're coming in at high velocity, you have to shed a lot of that energy to slow down, so you have an aero shield.
Landing piloted missions on Mars will require braking and landing systems different from anything used to land crewed spacecraft on the Moon or robotic missions on Mars.
The biggest payload we've landed on Mars has been about 1 metric ton. And for human missions, we need to have at least 10 metric tons landed, and preferably 20 or 30. So we're going to have to scale up.
The improvement of safe landing techniques on Mars is, then, a priority. The NASA's project Journey to Mars will investigate the entry, descent, and landing techniques needed to reach the Martian surface, which will guarantee the success of the first manned mission, scheduled for the 2030s. NASA has also already started to study closely what the best location for our first home on Mars would be. These should be locations of high scientific value that would also provide resources to allow human explorers to live on Mars. Local natural resources such as water and oxygen are crucial for humans to explore Mars. Liquid water might be obtained from 3 sources: ground ice, which would be buried or beneath the surface, the atmosphere, or hydrated minerals. Oxygen, by comparison, can be generated from the carbon dioxide that makes up most of Mars's atmosphere.
There's a lot of disagreement about where the Mars base should be. The poles have an advantage because there's water ice there. But the problem with the pole is it's dark for half a Martian year, which is, say, almost a full Earth year. So that leaves you either with the equator regions or the mid-latitudes. They both have something to argue. The equator is the warmest, varies the least with season. But if you go to mid-latitudes, you can get places that always have at least some sunlight all year long, but which have some water ice too. Not big fields of it like the pole, but nevertheless deposits of water ice that are readily accessible.
My favorite site, we call it Noctis Landing, and it's in the western end of Valles Marineris, which is this giant canyon that cuts the surface of Mars. I love this location because it's at the bottom of the canyons, but at the same time it's in an area that's very wide and very open, so that you can see the Earth easily in the sky and maintain communication.
Other possible places considered for a first location on Mars are paradoxically outside the planet. They are the small moons Phobos and Deimos.
The Martian moons are the sweet spot when it comes to a potential settlement site.
We should use Phobos and Deimos as targets. We should send first early crews just to make sure we can travel to Mars and come back safely, not to get too complicated. That will be already a fantastic adventure.
Both of them are much smaller than our moon. Phobos' mean diameter is 14 miles, and Deimos is just 7 miles, while our moon diameter is around 2,100 miles. The fact that they are much smaller means their gravity wells are almost non-existent. So landing and takeoff would be much easier than on the Martian surface.
The Martian moons are locked like our moon. They always keep the same face facing Mars. So if you wanted a place to explore Mars robotically, the best place to do that from is from the Mars-facing side of Deimos. Deimos is 20 times closer to Mars than our moon is to the Earth. So the round-trip light time to to control things telerobotically is just a little more than 100 milliseconds.
These two little moons, so very close to the planet, might be used as a pit stop for the exploration and future colonization of Mars, and even for the colonization of the asteroids of the main asteroid belt in orbit between Mars and Jupiter.
I think that they are very exciting places as a first step for humans to explore Mars. The very first missions to Mars, I think, should not try to land on Mars.